Hello, welcome to Ostwald Viscometer experiments. Liquid viscosity is a measure of frictional force between the layers of a liquid. Viscosity is a popular quantity or value in liquid, often used as the identity of the liquid. The viscosity of soy sauce is different from oil and vinegar. It means that it should be something going on or something happen or something different between the soy sauce, oil, and vinegar. It could be anything. It could be depend on the temperature. It could be the density, or it could be anything. So the goals of these experiments are to find the viscosity of a saline solution or natrium chloride with different density with the Ostwald viscometer. So here we have a figure 1. Figure 1 itself is the frictional force between the fluids. Friction G between two flow substances in figure number 1 are equal to the area or A and change in velocity or dV and unequal with the change in distance or dy. So we can construct a mathematical equations in this information to the equations here. So the G are equal to the A times the difference of the velocity with the distance or y, or can be rewrite as equation number 1. So we have the eta symbol here. With eta is equality constant called viscosity. Viscosity or eta value depends on the temperature and some other factors. When fluid flow in 1 cm pipe and have a radius of r, because of difference in pressure of P between both ends of the pipes makes fluid substance volume that flow per time unit fulfill the Poisson equations or the equation number 2. So the volume are equal to the pi times the radius with the times of 4 times the P or the pressure times the flow time per unit and divided with the h times the eta or the viscosity value. We can see that the volumes are proportional with the pressure and the time or the flow time and inversely proportional to the eta or the viscosity value. Because P are proportional to the S, which S is the density of the liquid, then we get this equation. So the volume are equal to the density of the liquid times the flow unit, and we divide it with the velocity. Oh, I'm sorry, when we divide it with the viscosity. To determine the viscosity of a fluid, we use the Ostwald viscometer method, which let it flow the observed liquid in a vertical pipe. Those pipes are in the thermostat. The upper part of the pipe is expanded to serve the observed liquid that will be flowed. If the time required for the first liquid to flow from A point to the B is flow time 1, and time required for the second liquid to flow from the limit A to B is flow time 2, with the same volume, hence we can construct this information to the mathematical equations in equation number 3, of course. So the eta or the viscosity value of the first liquids are equal to the density of the first liquid times the flow time of the first liquid, and so on with the second solutions. In these experiments, the first solution is a saline solution or natrium chloride with different density, and the second solution is the aqueous. In natrium chloride solution viscosity and aqueous solution viscosity, then the viscosity itself obey this equation. So the eta measurements or the viscosity measurements are equal to the viscosity of the solutions divided by the viscosity of the aqueous. We got the aqueous viscosity from the observational data. If the density of the solution and the density of the aqueous are been known, and also inside the Ostwald viscometer, the time required for the natrium chloride solution to flow in second and aqueous solution to flow in second are been known too, then we get, or we can construct it to this equation. So the viscosity solutions are equals to the density of the solution times the time flow of the solutions, and divided by the density of the aqueous times the time flow of the aqueous, and with times this with the viscosity of the aqueous. It means the aqueous viscosity can be determined based on the equation above, so that we can get the measurement viscosity in equation number 4. When the density of the natrium chloride solution and aqueous has been discovered, we can find the viscosity error from the flow of natrium chloride solution and aqueous. The apparatus of these experiments are Ostwald Viscometer, aqueous pump to pump the solution into the Ostwald Viscometer, beaker as an observed solution container, natrium chloride solution with the density variant, and stopwatch to measure the time of solution from flow from the A point to the B point. So the set of the apparatus can be shown in figure number 3. It should be 3 here. It's kind of like this. So this is the A point and this is the B point. I forgot to write the A and B. The method of this experiment, of course, we set the apparatus as shown in figure number 3 here, and we pump the aqueous solution into the Ostwald Viscometer until it reaches the A point, or here the A limit here. Let it flow until it reaches the B limit, or here B point. The duration of the aqueous solution flow from A point to the B noted as T, or the flow time. We repeat step 2 and 4 for 3 times and note it as T1, T2, and T3, or flow time 1, flow time 2, and flow time 3. And then we repeat step 2 until 5 with 3 different density of natrium chloride solution.
Assalamualaikum warahmatullahi wabarakatuh. Halo semuanya. Pada kesempatan kali ini kita akan melakukan praktikum menentukan kekentalan zat cair. Tujuan dari praktikum ini adalah menentukan viskositas zat cair dengan variasi massa jenis pada larutan. Oke, selanjutnya ada alat dan bahan yang digunakan pada praktikum ini. Yang pertama ada bejana berisi air dengan suhu ruang, ada termometer untuk mengukur suhunya, di dalam ada viscosimeter Ostwald, ada pompa, stopwatch, juga gelas ukur berisi cairan aqueous, NaCl 15 gram per mililiter, NaCl 18,6 gram per mililiter, dan NaCl 22 gram per mililiter. Sekarang kita masuk ke praktikumnya. Pertama-tama perhatikan bahwa di viscosimeter Ostwald terdapat batas A dan juga batas B. Langkah pertama adalah memompa larutan hingga mencapai pada batas A. Lalu, biarkan air mengalir dari batas A hingga batas B dan hitung waktu mengalirnya dengan stopwatch. Setelah itu, waktu dicatat sebagai data percobaan. Oke, selanjutnya lakukan pengulangan pada larutan aqueous sebanyak 3 kali. Juga lakukan variasi dengan larutan NaCl 15 gram per mililiter, NaCl 18,6 gram per mililiter, dan juga NaCl 22 gram per mililiter. Oke, seperti sudah dijelaskan pada sebelumnya, waktu dari batas A hingga batas B dicatat sebagai T dan dilakukan pengulangan sebanyak 3 kali. Lalu dilakukan variasi juga dengan larutan lain, yaitu NaCl 15 gram per mililiter, NaCl 18,6 gram per mililiter, dan NaCl 22 gram per mililiter. Oke, sekian, terima kasih. Mohon maaf bila banyak kesalahan. Wassalamualaikum warahmatullahi wabarakatuh. Selamat mengerjakan laporan.
In these sections, we will discuss about the data analysis that we use to get the value of the viscosity. So, the duration of solution flow from limit A to limit B with 3 repetitions, and the average value of the flow time can be found with equation number 5. And the uncertainty or the error of the average of the flow time can be found with the equation number 6, or the expanse of the equation number 6 with n r equals to 3 or 3 repetitions can be shown in equation number 7. To find the viscosity or eta dynamic of solution, or eta dl, we need to know the viscosity measurement of the solution as shown in equation number 4 before, or on the first hand, equation number 8. So the eta, or the viscosity of the measurements, are equal to the density of the solutions times the average flow time of the solutions, and we divide it with the density of the aqueous times the average flow time of the aqueous. And the uncertainty or the error of the eta measurements can be found with the equation number 9. And when we get the eta measurements or the viscosity of the measurements, we can find the eta dl, or the viscosity of the dynamic of the solutions, with equation number 10. And the uncertainty or the error of eta dl can be found with equation number 11. With this equation, we can find the eta dl for each solution with difference density. So this is the observational data that we get, and you will use this to get the viscosity for each density variations. And that's it. Good luck. Please ask your assistants for more information. And yeah, good luck.